Today we're going to talk about the antiderivative. Let's start from the definition. The sign define a function f(x). The antiderivative f(x) can be considered as the operation that goes backwards from the derivative function to the function itself. Since we know the derivative of the function does not determine the function completely, so we have to add additional information to go back to the function. This process can be defined as the antiderivative. For any constant we assign here as c, that's not going to affect the derivative of the function f(x). Antiderivative sometimes can be referred as indefinite integral. So what's the difference between definite integral and indefinite integral? Previously, we summarized definite integral can be demonstrated by using the graph, finding the area bounded below the function f(x) in the range from a to b. It will return you a value. However, indefinite integral is only an expression with term of variable in your sign. In this case, is x. So we have the three basic properties of antiderivative. The first one, when you multiply by the constant, you can pull out the constant outside the integral sign. When you finding the integration of combining two functions, you can first take integral of each function and then combine them together. For the integral of product and quotient, we'll use various methods to solve the integral. The following integration do not hold. So basic rule of the integrations. For solving exponential function, trigonometry function, and inverse trigonometry functions, we need to remember those properties. I want to mention, whenever you see the integration of 1 over x squared plus 1, you should automatically think this is the inverse of tangent. Define this property from your back of the textbook as well. Let's look at the four popular of the integration method. First one is substitution. Integration by parts, partial fraction, and trig substitution. Let's do one more exercise. Find the integral of 2x times square root of 4 plus x squared dx. So the first thing is, how can I simplify the functions by using substitution? And what I can assign u to be part of the function. Let u to be 2x. So du is 2. What about the addition of this term? It's not going to help too much. So how about u to be 4 plus x squared? And du become 2x. It works perfectly. So my function becomes integration of u to power 1/2 and becomes 2 over 3 u to power 2/3 plus constant. And then I substitute back 4 plus x squared in terms of u. There's my solutions. I want to emphasize here, you cannot combine the new variable, your sign, and the previous variable in the functions together. For example, in this equation, integration of 2x plus times square root of 4 plus x squared plus x. So you cannot write this substitution in terms of u and x together. This is a big mistake. Let's do another questions. So by using the substitution, I can think about assign u to be e to power x, and du is the same thing. But I don't see any modification of combination u and du together. How about simplifying the function first? So the function becomes 2 times e to power x I see the probably du terms here, and divide by e to the power 2x plus 1. So I think my assumption is right. Let u to be e to the power x, and du is e to the power x dx. And then my function becomes integral 2 times du divided by u squared plus 1. And this is the inverse tangent. So here's my solutions. Let's do one more exercise. This question we'll apply the trigonometry substitution method. Whenever I see the signal 1 over square root of 4 minus x squared, it tells me this I know a is 2 and b is 1. So I can write my substitution here that x becomes 2 times sine theta and dx is 2 cosine theta. It's cosine theta d theta. Substituting into the function, we have the expression, and then simplify again. Cancel the 2 times cosine theta terms. Left with 1 over 4 integral cosecant theta d theta. Cosecant theta squared d theta. Then becomes the minus 1 over 4 cotan theta plus c. And now finish it. To find the cotan theta, we have to apply the Pythagorean theorem by drawing the right triangle. We have the theta here. The opposite is x over 2. The hypotenuse is 1. And the adjacent becomes square root of 1 minus x squared divided by 2. There comes my cotan theta. It's square root of 1 minus x squared divided by x. So I have my solution right here. If this question worth 5 marks, when you write this first substitution, you get a first mark, and then you simplify the function after substitution, you get second mark. You applying trigonometry property, you get another mark. You have your Pythagorean theorem, the right triangle, you get another mark. And your final solution, you get a last mark. Thanks for watching.